Morning. Am I audible to you guys? Am I audible? Okay. Okay, so today I'll start with again a small portion of your modular arithmetic. One topic was left, which is Chinese remainder theorem. Let me share my screen. So it is. Hello, morning. Ini daya tu bahasa ni sekolah. Ini naik mana rasa dah sekali. So yes. So Chinese remainder theorem is another small topic of modular arithmetic. So according to Chinese remainder theorem, suppose there is a okay, I just write for a given pairwise co-primes. I hope you guys now know what is co-prime. Suppose n1, n2, and nk, and arbitrary integers a2 up to ak, the system of components of n1, x is n2 to suppose x equal to ak mod nk. Then if it's like if there are certain series of expression, congruent expression, then that solution, the solution for this sequence of equations will be a unique modulo of n. Solution is unique. Okay, so this is your the main theorem. For example, if you have like a series of expressions, congruent expressions, then that method will have a unique solution, and that unique solution can be given by these equations. Okay. Now we have different steps to calculate the Chinese remainder theorem or solve an equation with the help of Chinese remainder theorem. I can just give you an example. So this is the main theorem. I'll just show you an example. For example, we have expressions like 1 mod 5, then x is congruent to p 7. Then there will be a unique equation or answer. That means we have to find x such that if that x is divided by 5 or x is divided by 7, the remainder is 1 or 3. Okay. Now main condition is that these numbers should be co-primes. Now here 5 and 7 are your co-primes, right? These are co-prime. What is co-prime? Co-prime. What was co-prime? What is co-prime? One is divisible. Only one is divisible. Co-primes. Co-primes means co-prime or relatively prime. The GCD is 1. Okay. So before doing any of the solutions, what you need to first take care of, you have to take care of that these numbers are co-primes. Other than that, how we can find that? The first condition is I didn't have. I have a row. So একদম সব লই আনিছ যে? Okay, so to solve an equation, we need to make sure that GCD of the numbers, for example, this here I have written a and n. So if I just make it like suppose x equal to a1 mod m1. Hello. हाँ CNS number Okay, sorry. So suppose these are our equations. Letter এটা চেঞ্জ হৈছে যদি আপা বাই দি দিবা ওকে তোমাক কোনদিনা ক্লাছ আছে so GCD suppose M1 this is just the procedure how you need to find the solution okay so first you have to make sure the conditions needs to satisfy is GCD of M1 M2 and GCD of M1 M3 or this is the condition okay M2 M3 this all should be equal to 1 okay that means all the numbers this M should be your co-primes and how you can find the solution for X the equation will be like for X we need to find out M1 X1 E1 I'll tell you what is M2 and on X2 E2 and Mn Xn and En and this whole mod M okay now what is M right so M you can say is M1 into M2 into M3 up to Mn it will depend on how many expressions you have if it's 2 then M1 M2 2 A3 and so on so this is your capital M now we also need to find Mi right so Mi you can find M divided by for every small m okay the capital M is the into of all these m's then Mi you need to find it out which will be the total m divided by respective Mi for everyone okay but example here like M1 will be m by M1 okay so it will be M1 M2 M3 for that particular equation equal to M1 okay so these are the conditions first you have to check whether these are co-primes or not if they are co-primes then you can say that X will have a unique solution and that unique solution we can find with the help of this equation so this equation from here you can further make it small M2 and M3 okay so similarly your M2 will be M1 M3 and M3 will be M1 and M2 so these are the things you need to find out okay so again then this expression you can also just make it a bit small you can just write summation of Mi Xi Ai not M okay so main thing we need to find out these things okay so let's you just see the example one five one seven 3 on 11 okay suppose these are the equations we are given so we need to find the value of X with the help of Chinese remainder theorem so what I need to check first if these numbers are co-primes or not now see here these 5 7 and 1 all are relatively prime or co-prime to one another so we can find X okay since we can find X So we have to proceed with the further. First, remember we need to find capital M. Okay, so M was what? M1 into M2. We have only 3, so only 3 will be there. So what are the M's here? 5 into 7 into 11. What will be the answer? It will be 385. Okay, this is our capital M. Now we also need to find this small m1, m2, m3. So let's just find what is m1. M1 will be your m2 and m3. So if this is the m1, the m1 will be summation of these two numbers, because you are trying to find for this one. If you are trying to find m2 for this one, the equation will be 5 into 11. Now here m2 into m3, which will be 7 into 11, 77. Next you need to find m2. M2 will be m1 and m3. So it will be 5 into 11, which is 55. Next need to find m3, and m3 will be m1, m2. So it will be 5 into 7 equal to 35. Okay, for if you get confused, you can just write down what are your A1, A2 and A3. A1, A2, A3 is your nothing but this remainder values. Okay, 1, 1 and 3. 1, 1 and 3. These are your A1, A2, and for example M1, M2 and M3. You can also write down 5, 7 and 11. Okay, so now what's the main thing? We need to calculate xi. Okay, xi. So how we can find the value of xi? Xi is nothing but the inverse of your m values. Okay, so since it's a inverse of this m, we can also find with the help of a certain equation, which you can represent as x1 equal to, not equal to, it's congruent 1 mod m1. Okay, this is reversible to your m, but we cannot directly find this reversible of m, so we can find xi with the help of this equation. It is just inverse of mi. So this xi is, you can say, inverse of mi. Now this equation you can also write like m1 x1 mod m1 equal to 1. Correct? Why? Congruent to, this means what? This number divided by m1 and the remainder will be equal to 1. That's the condition. The main, this equation you can just write in the form of this. Whole modular arithmetic is what? This expression divided by m1 and remainder will be 1. Okay, so how will you find? If you find it for the first one, our m1 was 77, x1 mod 5 equal to 1. Now what we need to do? We need to find this x1. How we will find x1? We need to multiply x1 by 77 and divide it by 5 such a way that the remainder is 1. Okay, what could be the possible ways? Just it's more like brute force method means you just need to find out. You can just start from 1, 2, and 3, 4. 77 into 5 into 11 is 5 into 11 is 55. Then what's the next value? 55 into 3. Okay, we can just take this one only. So now in this case, we can just is it to x2 mod 5. Okay, equal to 1. We just reduce the value. So after that, we can just find x1 equal to 3. Okay, here we just reduced it. What I did here, this is the a bit minimized expression. Now if you multiply 2 into 1, 2 mod 5, it's not applicable. Then 2 into 2 divided by 5, not applicable. If I multiply 2 with 3, 3 into 6, 6 divided by 5, and remainder will be 1. So here the value is 1. So next we need to find out what is M2. This is our x1. Now again need to find out for x2. Okay, sorry. Next we need to find out M2 x2. 1 mod M2. It's a bit lengthy. Just you need to follow the main rules. Okay, for M2 we have 55 and x2 mod 7 equal to 1. So, we just can just a bit minimize it. X2 mod 7 equal to 1. So we need to find a value for x2 such that if we multiply with 6 and we divide by 7, the remainder will be 1. So if I multiply 6, 6, 36, uh, 7 into 5, 35, it will be 6. So x2 will be 6. Okay, if I multiply 6, 6, 4, then 7 into 1, remainder will be 1. Okay, so next we need to find out M3 x3 1.21 mod M3. M3 is your 35. Just minimize it again. X2 up 1. So if you divide 6 into 2, 66, then divided by 11, remainder will be 1. So x3 we can say 6. So now we have found out all x1, x2 and x3. So finally the main equation is what? Summation of all divided by m, right? So your final x is m1 x1 a1 plus m2 x2 a2 plus m3 x3 a3 mod m. Okay, now you just put the values. M was 77, x1 we just found out is 3, a1 was your 1. Similarly, m2 is your 55, x2 was your 6, 6 and it was 1. Okay, next m3 is your M3 is 35. 35 into 6. A3 was your 3. Okay, and finally this whole thing is mod M. M is your 385. 385. So you just multiply these things. I'm just using my calculator. So values will be 231 for this one. 0 and for this one 6.0. And this whole thing is mod 385. Okay, now 191 mod 385. Okay, so we need to find the x now, and for this x will be x equal to 36. Okay, so this is the solution using Chinese remainder theorem. Okay, if you check, if you want to verify, the answer can be like, okay, if you don't want to use calculator for this, what we need to do, you can just find out 1191 minus 385. Okay, then answer will be 806. It's quite a big number, right? It's a bit difficult if you don't use the calculator, but if you don't have calculator, you can just divide this value, sorry, not divide, it's subtract this value from this value and keep subtracting the value until you get any value which will be less than this number. Okay, so 806, again, if this is greater than 385, then you do 806 minus 385, value will be 421. Then still it's bigger than 385, 421 minus 385, and the value is 36. Okay, since 36 is less than 385, our main solution is x equal to 35. Now suppose you just want to verify, you can check whether 36 mod 5 equal to 1, correct? Again 36 mod 7 equal to 1. 7 into 5, 35. 36 minus 35 is 1. 36 mod 11 is 3. 11 into 3, 33, 36 minus 33 is 3. Okay, so this is our unique solution. So it's a bit long, but the main thing is first you need to check whether the numbers are co-primes or not. If they are co-prime, then only you can find the value of x with the help of Chinese remainder theorem. So you just need to find what are the a1, a2, a3, then find m1, m2, m3. After that, just find first capital M, then find m1, m2, m3. The equation is like if you are just finding m1, the value will be multiplication of other two. Okay, if you don't want to remember this equation, just remember if you are finding for one equation, then m1 will be the multiplication of other two m's. Okay, so after calculating this, you need to find xi. Xi is the inverse of mi. Okay, since inverse of mi, we can just write mi xi is equal to congruent to 1 mod m1. That means this expression divided by m, remainder will be 1. So we can just simplify it like this equation. Then for every m1, m2, m3, you need to find the value of x1. Okay, so once you get the all values of x1, x2 and x3, finally you can just put it in the main equation, by which you will, this is your main Chinese remainder theorem equation. So after that you will find x, and x is the main solution. It's a bit confusing, not exactly, just that because the value of x1, x2, x3, you need to find out a bit, means it's more like brute force thing. It's hidden value, you have to check for each value. Okay, so up to this thing your modular arithmetic is finished. So we have mainly checked your uh, modular arithmetic number theorem, Chinese remainder theorem, Fermat's theorem, then primality test and all. Okay, if you want to write it down, you can just write down. Is it okay? Nijora, তুমি second class লবা না? Yes. Okay, Nijora ma'am will বলো। Nidora ma'am will not take this class at this time. She will take class in like your project class. So just take like 15 to 20 minutes break, then we will continue. So in next class, we will mainly discuss about message authentication. Okay. Just let me know if you have no project class today. Then maybe she will take. Okay. Thank you.